Hey, so it's our turn to discuss the last question of this paper. That's question number 37. So here we have the first part of first choice of question number 37, which says write two important characteristics of equipotential surfaces. Let's have a look on to the properties. So basically equipotential surfaces are the surfaces that have the equal potential at all the points. So if we try to write down the properties, so we know work done in moving a charge slowly on an equipotential surface is always zero. Also, electric field lines are always perpendicular to the equipotential surface. तो अगर आपने दो प्रॉपर्टीज इक्विपोटेंशियल सरफेस की लिखी हैं, you are going to get 1 mark for this part of the question. So basically half mark you will be getting for each of the property. Okay. Now here I have the B part of this first part of question number 37. This says a thin circular ring of radius r is charged uniformly so that its linear charge density becomes lambda. Derive an expression for the electric field at a point P at a distance x from it along the axis of the ring. Hence prove that at a large distances, that is x is much greater than r, the ring behaves as a point charge. Let's have a look on to the derivation. This derivation was for 4 marks. So basically if you have done this correct derivation and you have proved that at the larger distances this ring is going to behave as a point charge, you are going to fetch 4 marks for this part of the question. Let's have a look on to the derivation quickly. So what we are going to consider here is there is a ring of radius r which is having the linear charge density lambda that we have considered here. अब यहाँ पर हमें फाइंड आउट करना है इलेक्ट्रिक फील्ड इंटेंसिटी एट अ पॉइंट. सो वी आर टेकिंग द पॉइंट टू बी एट अ डिस्टेंस x फ्रॉम द सेंटर. ओके, वी आर एज्यूमिंग द इलेक्ट्रिक फील्ड टू बी E. नाउ व्हाट वी आर गोइंग टू डू इज वी आर गोइंग टू स्प्लिट द रिंग इनटू smaller elementary length dl. So we will be taking up the part of the ring, okay, of length dl. Now the charge on that part of the ring or that length is going to be lambda into dl. Now if we talk about the magnitude of the electric field due to that elementary charge dq, that is going to be 1 upon 4 pi epsilon naught dq divided by the distance of that point from the point where we are going to consider the electric field intensity or where we are going to calculate the electric field intensity. So this distance is going to be, this is x, this is r, so this is square root of r square plus x square. Okay, so this is what we have done here. Now when we will resolve the components of this dE, what we are going to get here, see, when this dE will be resolved, we will get dE cos theta and we will get dE sin theta. Now what will happen, see, component of dE sin theta will cancel out for whole ring due to symmetry, and hence the net field is going to be there due to the cos component of the electric field only. And hence what do we need to do? We need to integrate this and hence we need to integrate this component of the electric field to get the net electric field at that point. So when you will substitute the values and when you will get the final result after integration, you will get the electric field as 1 upon 4 pi epsilon naught lambda x divided by r square plus x square raised to the power 3 by 2 into 2 pi r. Now if the total charge on the ring is q, I can write lambda into 2 pi r as q. So when you will substitute the value, you will get E as 1 upon 4 pi epsilon naught qx divided by r square plus x square raised to the power 3 by 2. Now for far away points, if x is much greater than r, I can eliminate or neglect this r from the denominator and I will have the final expression of E as 1 upon 4 pi epsilon naught q divided by x square. So here you can see through this expression we can prove that this is behaving as a point charge because this is following the inverse square law. So we can say that this charge loop is behaving as a point charge. So for this derivation you will get 1 mark for drawing this diagram as well as writing about that how you are considering the different things, you are considering the elementary charge and everything, then you will get 2 marks for writing this entire derivation. You will get the final 1 mark for writing the relation or writing the comparison of this relation with the inverse square law, and this is how you will fetch complete 4 marks for this part of the question, and this is how you will fetch 5 out of 5 marks for this choice of question number 37. Now let's have a look on to the second choice of this question, that's question number 37. इस क्वेश्चन में हमसे पूछा गया था स्टेट गॉस लॉ ऑन इलेक्ट्रोस्टैटिक्स एंड डिराइव एन एक्सप्रेशन फॉर द इलेक्ट्रिक फील्ड ड्यू टू अ लॉन्ग स्ट्रेट थिन यूनिफॉर्मली चार्ज्ड वायर एट अ पॉइंट लाइंग एट अ डिस्टेंस r from the wire. Let's have a look on to the solution. तो एज पर द गॉस लॉ अगर हम बात करते हैं तो गॉस लॉ स्टेट्स दैट इलेक्ट्रिक फ्लक्स ऑफ रिजल्टेंट इलेक्ट्रिक फील्ड थ्रू अ क्लोज्ड surface is 1 upon epsilon naught times the net charge that is enclosed by the surface. So, integral of E dot ds, the total flux linked through the surface will be Q net divided by epsilon naught, where Q net is the net charge enclosed by the surface and epsilon naught is the permittivity of free space. Now, if we talk about the derivation that was asked in this part of the question, due to a straight, we need to calculate the electric field due to a long straight wire. So, here we need to consider an infinite long thin wire with uniform linear charge density lambda. To calculate the field, what we are going to do is we will be imagining a cylindrical Gaussian surface as shown in the figure. So here you can see we have imagined a cylindrical Gaussian surface. Now since the field is radially everywhere, therefore flux through the 2 flat surfaces of the cylindrical Gaussian surface is 0. Okay, so here you can see as the field is radially outward, so if we talk about this surface as well as this surface, if I am just going to name this as surface 1, surface 2 and surface 3. So these 2 flat surfaces are not going to contribute to the flux because electric flux is outward and the area vector is going to be perpendicular to these 2 flat surfaces. So the angle will be 90 degree and hence the electric flux contribution from these 2 flat surfaces is going to be 0. Hence we can say the flux through the Gaussian surface will be flux through the curved cylindrical part of the surface. It will be E into 2 pi RL. Okay. So basically what is going to be the flux? That is E ds cos theta. Now here if you will just take the small area element, that is also going to be radially outward and hence the angle is going to be 0 between the electric field and the area element. And I can say that E or the flux will be equal to E into 2 pi RL simply. Okay. Now, if we talk about the curved surface, that is going to include the charge that is equal to lambda into L. So, Gauss law can be given as E into 2 pi RL is equal to lambda L divided by epsilon naught. And this gives us the electric field as lambda upon 2 pi epsilon naught into R. And in the vector form that can be written as lambda upon 2 pi epsilon naught into R into n cap. Okay, so n cap is the radial unit vector in the plane normal to the wire passing through the point where we are calculating the electric field. So for this entire complete derivation which was asked to you in this part of the question, what we are going to get? This part of the question was for 3 marks. So you will get 1 mark for writing the expression for the Gauss law as well as the statement of the Gauss law. For this complete derivation आपको 2 marks मिलेंगे. You will be getting 1 mark for explaining that why these flat surfaces are not going to contribute to the electric flux. Then you will be getting 1 mark for the rest of the calculation, and this is how you will be fetching 3 marks for this part of the question. Let's have a look on to the part B of this choice of question number 37. इस part में हमसे पूछा गया था the magnitude of electric field in Newton per coulomb in a region varies with the distance r that is given to us in the question. By how much does the electric potential increases in moving from point at r is equal to 1 meter to a point at r is equal to 10 meter? Let's have a look on to the solution for this question. So यहाँ पर इस क्वेश्चन को सॉल्व करने के लिए आपको पता होना चाहिए था व्हाट इज द रिलेशन बिटवीन द पोटेंशियल एंड द इलेक्ट्रिक फील्ड. वी नो E is equal to minus dV by dr. So what will be dV? dV will be minus E dr. Okay, so basically potential difference जो होगा that will be minus E dot dr. So to calculate the total potential difference we need to integrate the dot product of E and dr. Okay, because both are going to point in the same direction, so that will be equal to cos theta will be equal to 0 and hence that will simply be written as E dr. Okay, now here I have just substituted the value of E as 10r plus 5 that is given to us in the question. So when you will integrate this expression you will get VB minus VA as minus 540 volt. So you can see that the potential increases by 540 volt in moving from the point r is equal to 1 meter to r is equal to 10 meter. So this is how there is going to be the change in the potential when we are moving from point A to point B. I hope this question is also very clear to you. You will be getting 1 mark for solving this question till here and you will be getting 1 mark for deriving the final result. So this is how you will be fetching 2 marks for this part of the question and this is how you are going to get 5 out of 5 marks for this choice of the question. And with this we have came to an end of our discussion of physics paper. अगर मैं फिजिक्स के पेपर की बात करूँ डेफिनेटली पैटर्न चेंज हो जाने की वजह से नंबर ऑफ क्वेश्चंस बढ़ गए हैं लास्ट ईयर के कंपैरेटिवली. सो ये पेपर जो है दिस इज मोर ऑन टू द लेंथियर साइड. ऑब्जेक्टिव टाइप क्वेश्चंस इंट्रोड्यूस होने से, फिल इन द ब्लैंक्स टाइप क्वेश्चंस इंट्रोड्यूस होने से, सो स्टार्टिंग के 20 क्वेश्चंस जो थे वो 1 मार्क क्वेश्चंस थे. बच्चे इजीली इसमें 1 मार्क्स यानी कि 20 मार्क्स इजीली स्कोर कर पाएंगे. जो डेरिवेशंस पूछी गई थी पेपर में वो बहुत जेन्युइन डेरिवेशंस थी. अगर आप प्रीवियस ईयर के बोर्ड के पेपर देखेंगे तो ये डेरिवेशंस रिपीटेडली पूछी जाती हैं, तो डेरिवेशंस में कोई भी दिक्कत नहीं थी. लेकिन अगर मैं बात करती हूँ न्यूमेरिकल्स में, तो न्यूमेरिकल्स में जो क्वेश्चंस पूछे गए डेफिनेटली उन क्वेश्चंस के अंदर बिना कैलकुलेटर के जब आप कैलकुलेशन करोगे दैट इज गोइंग टू कंज्यूम अ लॉट ऑफ योर टाइम एंड हेंस ये पेपर जो था दैट वाज मोर ऑन टू द लेंथियर साइड. So this is all from my end. I just want to wish you very good luck from the entire Akash family for your results. I hope you will be able to estimate your score for this exam and I hope you will get the same result as well. Thank you so much for watching.